Good evening. Here in this lecture, I want to discuss about acceleration due to gravity. The chapter is gravitation. You know this thing. Only one lecture was delivered uh, from this chapter. The topic was Newton's universal law of gravitation, where you have got force is equal to force of attraction between two point particles is equal to G, capital G into M1 into M2 divided by R square, where the M1 and M2 are the masses of the point particles and R was the distance between them. So using that formula, we are going to derive the expression for acceleration due to gravity. If any object is on the surface of Earth, so object is having some mass and the Earth is having also some mass. So they are attracting each other. They will attract each other. So the force of attraction is acting on that object of small mass. Since force is acting on that small object, therefore there must be some acceleration of that object. That acceleration is called acceleration due to gravity. So, say for example, this is our Earth, okay, and this is the center. This is what? This is Earth, E-A-R-T-H, Earth. And this is what? This is the radius R. Capital R is the radius of the Earth. And suppose there is one small object on the surface of the Earth. Okay, small object. This object is having the mass of small m and this Earth is having the mass of capital M. Capital M is the mass of the Earth and mass of the object which is kept on the surface of the Earth is having the mass of small m. Therefore, force of attraction between them is what? Force of attraction, if it is denoted by capital F, then capital F is equal to capital G, capital M, small m divided by R square. Here, at the center of the Earth, means this point, here the entire mass of the Earth is assumed to be concentrated. That's why we have taken this distance from this point up to the object. What is that distance? That is equal to the radius of the Earth, because the size of this small object is very, very small as compared to the size of the Earth. Okay, so dimension of this small object need not to be considered. Okay, so that's why we can use this formula F. Now, so this much of force is acting on this small object. Then what is the acceleration of that object? Therefore, acceleration of that object is equal to force divided by mass of that object. Right? Acceleration of this object is equal to force divided by mass of the object. Force is this, means this, divided by m is what? It is equal to 1 by m into G m by R square. G capital M small m by R square, which is equal to capital G capital M divided by R square. Okay, so acceleration is this much. This acceleration is called acceleration due to gravity. And acceleration due to gravity is denoted by a symbol small g. Okay, therefore small g, that this is equal to capital G into capital M divided by R square. Okay, this is small g. Okay, small g. You can see that the acceleration due to gravity in the right hand side expression, mass is not present. Mass of the object, mass of the small object is not present. That means acceleration due to gravity is independent of the mass of that object. Acceleration due to gravity depends only upon the mass of that Earth and the radius of the Earth and nothing else. and capital G is a universal constant, so that will not change anywhere in the universe. Okay, so G is this much. If you put the values of M and R for Earth, radius is almost 6400 kilometers, 6,400 kilometers. In some books, you will get also 6,375 kilometers also. Okay, anyway, it is 6,400 kilometers on an average. Okay, if you put this value, if you put the mass of the Earth itself, you will get G almost equal to 9.8, and unit is meter per second square. 9.8 meter per second square. Though we know that our Earth is not actually exactly spherical. Okay, so since it is not exactly spherical, therefore radius of the Earth is not same everywhere. So there will be some change. Minor changes are there. Okay, that will be discussed in another video. So for this topic, acceleration due to gravity, we have got acceleration due to gravity can be expressed by this formula. And if this small object is kept at a height h from the surface of the Earth, suppose this object is kept somewhere here. Okay, whether I need to check whether everything is visible or not. Yes, everything is visible. Suppose this small object is kept somewhere here, mass is m, and this height, and this height from the surface of the Earth is h, small h. Okay, object is kept somewhere here. H is the distance of this object from the surface of the Earth. Then what will be G? In that case, G will be what? G will be capital G, capital M, and this R will be replaced by this R plus H. Okay, so what? So I need to erase this portion and write somewhere here. So in that case, small g will be equal to, this small g will be equal to capital G, capital M divided by R plus H whole square. Okay, if H is very, very small, as compared to the radius of the Earth, in that case, this H is taken to be simply 0. Okay, this H is taken to be simply 0. So this is all about acceleration due to gravity. Okay, in the next video, I will discuss another topic from the same chapter. Okay, thank you for watching this video.